We can use SPSS to find the best fitting line to do linear regression when we're looking at two quantitative variables. We did talk about first that we would graph our data. So if you go to legacy dialogues and go to scatter/dot, make sure this first option of simple scatter is selected and click define. You'll be able to put in what your x and y variable are. So what we'll look at here is whether or not height, we'll put that as our x, has an impact on shoe size. Let's put that as our y. Notice these are both quantitative variables. And what we'll see is a scatter plot of the relationship here between x and y. And so we do see that we have a linear relationship between height and shoe size, and it looks fairly strong to moderate. So we may want to look at then what is the best fitting line and also what is the correlation for this data. If we go to analyze and then go to regression and then go to linear, that is where we're able to get the information. So we put in our dependent variable as our y, so that is going to be shoe size that we want to enter there. And then what we're going to put in under our independent variable is our x, and that was our height. And we click OK, and we will from that get some information. In the model summary box, we have this value here of r, that is 0.854, so we can see we do have a strong positive linear relationship. One other number we talked briefly about was the sum of the squared errors or residuals, which is called SSE in the notes. That number is actually right here, 74.823, under sums of squares and residuals. So if we would take all those distances from every point to the line, square them, those residuals, add them up, we would end up with this value here. And then down here under the coefficients box is where we can get our equation for our line. We have a column called B, we have a constant, and then we have our x variable here. So this is going to say that our equation for our line is having an intercept of negative 17.330 and a slope of 0.396. So we would get y hat equal to negative 17.330 plus 0.396x. That slope is telling us that if your height goes up by 1 inch, you expect your shoe size to go up about 0.4. One other thing we could do if we want is we can actually get our residuals saved for us. If I go back to that process of regression linear, where I had entered the variables there, if you click on save, there's a whole bunch of options here, and one of them under residuals is we can click this box for unstandardized. Click continue, click OK. It'll run everything again, but what it actually did is if you go back to your data set and you look at the very end, there's been a new column here added for us. This column contains our residuals for every data point. So if you took this first person, you plugged in their x value of their height in and got their predicted shoe size and took the difference between that and their actual shoe size, this is the residual. So these are the numbers that if you square them all and add them all up, you get that SSE that I pointed out in the other bit of output.